Okay, welcome back, guys. This is Professor Roldan with Topics in Mathematics. This is section 3.5 or worksheet number 7 in your workbook, Symbolic Arguments. So let's get started with symbolic arguments. Everything we've learned so far is going to basically build on top of each other to come to this point where we are validating arguments. In this section, we're going to do symbolic arguments. That's what the and, or, if and only if-then statements. And then the next section, in 3.6, we're going to do syllogistic arguments with some, all, none, things like that. So first of all, I just want to say that this is a really good, in this section, we're going to be really applying our logic. So the things we've been learning, this is going to be a really good application, okay? Because this is going to help us basically draw, which means come to a logical conclusion of a given set of premises which basically just means statements, okay? Okay, so what is a valid argument anyways? So a valid argument is when its conclusion, the conclusion of your thinking, of your thoughts, which are coming out in statements, your conclusion necessarily follows, okay, from a given set of premises. So what that means is, doesn't mean that it's true, it just means that it is logically necessary, whatever your conclusion is. That's a valid argument, okay? An invalid argument would be the opposite, would be a conclusion that does not necessarily follow from a given set of premises. So basically, if you take a look at these are arguments with conclusions. So what you're looking at right now is something with premise 1 at the top. Then you have premise 2 on the bottom, and then your conclusion will be down here. Okay, and those 3 dots, I introduced those last time, but that means therefore in symbols. Okay. So to read the first one, it says if P, because of the arrow, one directional, if P then Q, P therefore Q. All right, is this a valid argument? And what this is saying here, that these are yes indeed all valid arguments. Okay, you have 1, 2, 3, 4, and 5. Okay, just for the sake of time, I'm not going to go over the names of those. Okay, I think the symbols are already a lot to deal with right now. So you may get some vocabulary questions in your homework. You can just look those up in the textbook. Okay, so what each of these are called. But why are these statements valid? Okay, so we have, oh no. Keep pressing the wrong button. Okay. So if P then Q is right here, and what happened to my and? Okay, it disappeared. So hold on. Okay, so we're going to do Q. I'm sorry, we're going to do the answer to that. So the answer to all this is right here. And if then Q is right here. So we're just going to look just like this. Remember, if then, you're looking for any scenarios where you get true, false, and we don't have that. That means that these are all going to be true, and they're all true. There's our tautology, okay? So that means the statement is valid. All right, so as you can see, it's not the funnest thing in the world unless you're like me, a little odd, but we could do this for arguments 1 through 5 right here, but we're not going to do that, okay? Just take my word for it. These are all valid, and it takes the truth table to kind of prove that. Before we get started, actually, you know what? Let's do a quick review on contrapositive, okay? So before we start actually applying this right here on the next page, we need to kind of quickly review contrapositives from the previous section. Okay, and so the contrapositive says if P then Q, the equivalent statement, okay, the equivalent statement, which means their truth tables match, is negate Q, negation of Q, if not Q, then not P. So we've proved this in 3.4. All right, or at least we've said it. So let me prove that statement here. And I'm going to go ahead and pause the video, and you can go ahead and do these two separately, okay? Which means you want to do this one here and this one over here, just to make sure, if you have any doubts, that these two statements are equivalent. So pause the video and complete the truth tables, and I'll unpause it in a few minutes, in a few seconds, and you will be able to check your answers, okay? So that way we can just move on. Okay, it should be done by now, and hopefully your answer matches mine, but basically you can see that even though these two statements are totally different, you can see that there is a match here. And if there's a match, that means they're equivalent, and we're going to be needing this later, okay? When things get a little messy. All right, so we're going to come back to this, but let's go ahead and practice doing some contrapositives. So it says, if the sky is blue, then it is sunny. So basically, you want to negate. So if this is P, this is Q, then you want to do the negation of both of those statements with the second part first. So if it is not sunny. That's just, if it is not sunny, then the sky, and negate this one, the sky is not blue. Okay, and I'm going to do the odds. So let's go to the next one. So we're going to reverse again, negate both, but reverse them, and an if then. So if it says not, that means it is now. If it is sunny, then negate that, so then it is blue. Then the sky is blue. Okay? Okay. All right, let's go to the next page and start applying these 5 arguments. Again, we will have to come back to this contrapositive towards the end of the assignment. Okay, so are the following valid arguments? I'm going to do number 5. Actually, I'm going to do number 4 and 5, okay? Okay, so if Tim paints the house, that's our P. The neighbors will be happy, that's our Q. The neighbors are not happy, then that's a negation of Q. Therefore, Tim does not paint the house, so that's the negation of P. So in symbols, it looks like this. If P, then Q. Second premise is negation of Q. Therefore, negation of P. Okay? And if you look at rule number 2, or argument number 2, sorry. You will see that this is not match. Okay, argument 2 looks like this. So that looks the same, but the conclusion is different. The conclusion says, I'm sorry, it is the same. So the conclusion is the same, sorry. Okay, so because there is a match here, okay, so this matches and then the conclusion matches, then we get a nice valid argument, okay? Or valid conclusion. Okay. So we want to make sure we can find our valid arguments, which create valid conclusions. So let's take a look at number 5. Number 5 is apple. The apple is red. So that's P. Or, so that's or. The apple is fresh. The apple is fresh is the second premise, so that's Q. Therefore, the apple is red. And the apple is red is P. So if you look at argument numbers 3 and 4, arguments number 3 and 4 need to have a negation in the second premise. Okay? So argument 3 and 4 look like this. So you can have the or in there, but you gotta have a negation of P in order to get Q, or you need to have a negation of Q in order to get P. Okay, so we cannot conclude that the argument is P if Q is not negated, okay? So this right here is missing negation. Therefore, it is invalid. Okay, that is not a match. Okay. Okay, let's take a look at 7. If it is sunny, then I am hot. It is not sunny. That's a negation of P. Therefore, I am not hot, or I am hot, sorry. So that is Q. Okay, so in symbols, let's go ahead and write, this is if P then Q, negation of P, therefore Q. Okay? And if you look at rule number 2, or argument number 2, it does not match. Okay. So since it's not a match, sorry, but it is an invalid conclusion. Okay. Okay, number 9. If the tank has fish, P, then the water is salty. If the water is salty, then fresh fish will die. Oh, that's a new statement, so that's R. Okay. Therefore, if the fresh water fish will not die, that's the negation of R, and the tank has fish, that's P. All right, let's put this all together on the side. If P then Q, if Q then R, therefore not R, if not R then not P. Okay, does this match one of our valid arguments? Okay. Okay guys, so if you take a look at argument number 5, does not seem to match, okay? And since it doesn't seem to match, you may think it's wrong. So both premises match. The conclusions don't match, but if we go back to our contrapositive idea, okay, if we do the contrapositive, we may get a match. So let's see. Okay, so the question is, are these two statements equivalent? Okay, and it seems to be so, that the contrapositive of if P then R is you reverse those two, or you switch places, you flip them, and you negate both, and there it is. So since this is an equivalent statement, these are contrapositives, therefore this is valid. Okay? Okay? Okay. Let's go to the next page. Okay, we're almost done. We have a few more here. All right, number 11. Okay. This time we're going to actually draw a conclusion, okay? And we want to draw a valid conclusion, not an invalid one. So we're going to use our 5 arguments to help us out. So if you drink tea, then you need a lemon. Second premise, you drink tea. Okay, so if we put this over here, the question is, what are you going to write right there for it to be valid? So you go to your arguments. If you look at argument number 1, we're supposed to conclude Q. And Q is, you will need a lemon. Okay? Okay, so we're coming to valid conclusions based on our arguments. Number 13, if you have lunch, then you will not be hungry. Okay, you did not have lunch, so that's negation of P. Okay. So the question is, what conclusion are we going to draw here, given that this is what we have? But if you take a look at argument number 2, it's almost a match. So you got to negate the conclusion, not the premise, and then you can conclude a negation of P. Okay. And since these don't match, so therefore, no valid conclusion can be drawn. Okay, so we're going to do number 14 and 15. Actually, sorry, we're going to do number 15. And we're not going to do 14. 14 has 3 premises. And we have to use truth tables in this section. And so I highly recommend that you skip this if you want to maintain your sanity. Okay. Yeah, we'll skip that one. You can look, I can show it to you. It's a lot of fun, but that's not going to be in your homework, and it's not on the test. So let's take a look at 15. This is something we can do with what we've learned so far. So Joanna works at Hollister, and Joe works for Walmart. Okay, if Joe works for Walmart, that's Q. Andrew works for Starbucks. Okay, that's R. So let's get those two down first. So P and Q, if Q then R, therefore if Andrew works for Starbucks, so the conclusion is an if then. Andrew works for Starbucks is R. Joanna works at Hollister is P. Okay, and so we can't look at the 5 arguments because we don't have this one at all. But we can do a truth table. Okay, so using a truth table, we're gonna see if this is valid. Okay, and if it's valid, that means that the final answer is all truths, which means that's called a tautology. All right. So let's do this one. So we have P, Q, and R. Okay, we have P, Q, and R. And these go together with and. Okay. So we got to do the P and the Q. We have to do and if Q then R. Okay. And then we're going to conclude, and our conclusion is an if-then. So we're going to do, actually, it's better if we do okay. So unfortunately, we have to break this up like this and try to get this done without causing too much headache here. So, all right. So we're going to look at if P and Q. That's the first 2 columns. So looking for 2 truths. So we have a true here. And, oh wait, I'm looking at the wrong one. Okay, so true, these 2 are true and the rest are false. Okay, so this is first. We gotta do this second. So the second premise is right there. So if Q then R, everything is true except for true false, which is this one, and true false would be this one. So true, 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 true. Okay. All right. So now we gotta do the and of both of those. okay? So that's going to be there's a true there, and that is it. Okay. Now fourth, we have to do this guy over here, and then this is going to be last here. So if R, then Q. All right, so this one we have to look backwards. So we're looking for true, false, and it is the third one. It's true, false, and the second to last. Wait. So true, false is false, and true, false is. Remember, we're looking backwards, okay? So everything else is going to be true. And now, finally, we need to look at, to answer this, we need to look at let's see, we need to look at this one and this one here. So we're looking for false scenarios for if-then, and we do not have any, guys, so this is all true. And since it's all true, it's valid. All right, well, hopefully that didn't drive you too crazy. Number 14 is actually much worse. So final answer is right here. All right, well, we'll see you in the next video.